Now, on 12.5, we're going to learn how to play with our logarithms. Idea is when we're multiplying, I can split it as the sum of two logarithms. Notice I'm keeping the same base. Let's see this as an example. Log base of 5, and I'm multiplying. I'm going to split this as log base 5 of 6 plus log base 5 of 9. I can expand it. I can make it bigger. The same thing, I can condense it. I can make it smaller. When I'm separating it with a plus sign, I'm going to condense it into the multiplication of one base only. So log base 7 of 8 times 12. Notice I'm multiplying because I was adding. Now 8 times 12, I can simplify it. So I'm going to go log base 7 of 96. Same thing with example C. 3x is the same thing as 3 times x. So I'm going to extend it. I want to expand it as log base 3 of 3 plus log base 3 of x. Now, on my first log base 3 of 3, I see my 3's repeat, and we just learned in a previous slide that is 1. So I have 1 plus log base 3 of x. Now, looking at example D, x to the third, let me rewrite that as x times x times x. I'm multiplying x 3 times. So I'm going to expand this as log base 4 of x plus log base 4 of x plus log base 4 of x. I see that I'm adding log base 4 of x 3 times. So that basically is 3 log base 4 of x. Now, a cool thing here, if you notice, the exponent came to the front. Okay, we'll keep that in mind. Now, another thing that we just saw, that multiplication, we split it as a plus. So division, we're going to split it as a minus. Let me rewrite this as log base 4 of 7 minus log base 4 of 9. Right, I'm going to expand it. Now, example B, I already have it separated as a minus, so I'm going to condense this as log base 5 of 6 over x. Example C, it's a division, so I'm going to expand it. Log base 3 of 27 minus log base 3 of 5. Now 27, I can easily rewrite that as 3 to the third. Notice how my bases repeat. I'm just going to get the exponent. So 3 minus log 3, base 3 of 5. Example D, I'm going to condense it. I'm going to make it smaller. I'm going to write this as log base 6 of 28 over 7, which is better known as log base 6 of 4. Right? 28 over 7 can be simplified. Now, a rule that we just mentioned is when we have an exponent, all we're going to do is bring it to the front. That's all we're going to do. That basically what helps out. So looking at this one, my exponent, all I'm going to do, I'm going to bring it to the front. So I'm going to rewrite this as 2 log base 5 of 4. My exponent, bring it to the front. So 5 log base b of x. Now, a radical can also be written as an exponent. Let me write this as log base b of 7 to the 1/2. Because technically the power is 1. That's 7 to the 1. My radical, my root is 2. As a fraction, I'm going to put powered over root. So that's how I got that 1/2. So I'm going to rewrite this as 1/2 log base b of 7. But the 1/2 can be written as log base b of 7 over 2. The fraction of the front can become a fraction of the entire answer. Example D, let me rewrite this as log base 2 of x to the 2/5. My fraction is powered over root. So that is 2/5 log base 2 of x, because I brought the exponent to the front, which is better known as 2 log base 2 of x over 5. Now in example E, I see that I have x to the fourth at the bottom. Let me rewrite this to begin with as log base 3 of x to the negative 4. So I'm going to finish this as negative 4 log base 3 of x. I brought the exponent to the front. Now, a couple rules that we're going to see is when the base, the number they repeat, my exponent that's going to be my answer. So here on example A, I see those 5s repeat. So my answer is just 4. On example B, I can rewrite this as log base 3 of 3 squared. I rewrote the 9 as 3 squared. I see the 3's repeat. My answer is just 2. Now, when the log is an exponent and the base is the same as the other base, when the bases repeat, those cancel out. So here, my answer is just 10. Here, my answer is just radical 2. We have a rule. We have a slide with the rules, which is you guys can see it. Now let's play with this. I'm gonna see this times, so I'm gonna split it. I'm gonna expand it. I'm gonna say log base 4 of 4 plus log base 4 of x to the third. Log base 4 of 4 is better known as 1. On my second log, I can do something with the exponent, and I'm gonna write this as 3 log base 4 of x. On example B, let me write the radical as a fraction. I have log base 7 of m to the over n to the 1/2, which is also known as log base 7 of m to the 1/2 over n to the 1/2. I got rid of parentheses. I brought the exponent to the inside. I see division, so I'm gonna expand it as log base 7 of m to the 1/2 minus log base 7 of n to the 1/2. Right, I expanded. Now the exponents, I'm going to bring into the front. So I have 1/2 log base 7 of m minus 1/2 log base 7 of n. My fraction of the front, I'm going to make it as a whole fraction. So I have log base 7 of m over 2 minus log base 7 of n over 2. I'm going to write this as log base 5 of a squared minus log base 5 of bc. On my first, I'm going to bring the exponent to the front. So 2 log base 5 of a minus this whole thing I know is going to separate as a plus. So log base 5 of b plus log base 5 of c. Distribute the negative on the front. So I'm going to have 2 log base 5 of a minus log base 5 of b minus log base 5 of c. Lastly, let me condense example D. My powered, I'm going to bring it to the front. So I have log base b of m to the fourth minus log base b of n. It's a minus, so I can condense this as log base b of m to the fourth over n.